Hey, you all, it's Mr. Farrell here. I just wanted to do some videos on what we've been learning about as it pertains to waves and using the different equations that we have covered so far in class. So the equations we'll be talking about today are the equations for calculating wave speed or velocity. So wavelength times frequency equals velocity. We're going to do those first. Actually, this video will just be focused on those. And then I'll make another video where we talk about the equations for frequency and period. Okay, so frequency equals 1 divided by period, or the period equals 1 divided by the frequency, right? Two variations of the same equation. We'll go over those in another video. Okay, so here we see our first question. So it says the frequency of a wave is 2 hertz, which means we have 2 waves being produced per second. And that same wave has a wavelength of 10 centimeters. Okay, so what is its wave speed or velocity? All right, so I'm going to go ahead and start solving this problem for us. First, we want to write our ICE method, right? So went ahead, wrote that. All right, making some lines just to set this up nice and neat for us. Okay, so now that I have that written out, let's go ahead and start walking through this process. So again, the ICE method stands for identify, categorize, equate, and evaluate. So I'm going to identify the measurements mentioned in this problem. That is 2 hertz. All right, let me go ahead and change this back to the drawing tool. Okay, so we have 2 hertz. That was one of the measurements. We also have 10 centimeters. All right, and the problem is asking us a question. So I always want to put a question mark right there because we want to identify what we're looking for. So we just identify all of the measurements in the problem. Now we're going to go ahead and categorize them. So 2 hertz is frequency, right? Hertz is a measure of frequency. It also tells us in the problem the frequency of the wave is 2 hertz. 10 centimeters is the wavelength. Remember, this is the Greek symbol that represents wavelength. The Greek symbol is lambda, which is like Mary had a little lamb, but with DA at the end of it. So lambda for wavelength. And then we are looking for the wave speed or velocity, so we put V. Now we categorized everything as there are different symbols or variables. Now we're going to go ahead and equate. So we're going to choose an equation. Now there's only one equation we have that solves for velocity. So we're going to put that here. And now we just go ahead and plug in everything to solve. So we have 10 centimeters for our wavelength. Our frequency is 2 hertz. And the velocity is what we're solving for. Okay. Now, off the bat, we want to make sure to change our unit of hertz because when we go ahead and multiply, we don't want to have hertz in our final answer. All right, so I see hertz right here. I'm going to cross that out and just write wave per second. All right, because that's what frequency is. It's a wave per second. It's a measurement of that. Okay. So now I'm going to go in here and after we've done that, multiply our numbers together, and then we'll multiply our units. So 10 times 2 is going to be 20. And now let's multiply our units. We have centimeters times wave per second. So that's going to give me centimeters and waves in the numerator, right? Because the only thing in the denominator is the seconds. So centimeters and waves in the numerator times wave in the numerator, seconds in the denominator. Now this is almost good. The last thing we want to do for this problem is erase where we put wave, because remember, we change hertz to wave per second. And we put wave there just to give us a clear understanding of what hertz is, but wave is not actually a unit that we're using. We put it there kind of as a placeholder to remind us, oh, hertz is wave per second. It can be anything per second, but it's a wave per second. So the wave is not necessary, it's just to remind us what we're talking about. So in my final answer, I don't actually want to put that. I just had used it as a placeholder. So my final unit is going to be centimeters per second. Let me just go ahead and write that. All right, centimeters over seconds. And that's my final unit. All right. So that seems pretty good. So we're going to go ahead and erase this and go through another problem, just a different variation, where we are solving for wavelength, and then we're going to do one where we solve for frequency. Okay. Let's erase the question. All right. So let's go ahead and solve for, well, let's solve for frequency first. All right. So we got the same problem set up. Okay. And in this problem, says a wave is traveling with a wave speed or velocity of 30 centimeters per second. The wavelength of the wave is 5 centimeters. What is the wave's frequency? So we're using the identify, categorize, equate, and evaluate method again. So I'm going to identify my measurements. So 30 centimeters per second. That was one of the measurements we got. And then 5 centimeters was the other one that shows up. And now we also put our question because we need to identify what question is being asked of us. So that's our identify step. Categorize, we need to match these measurements up with their symbols. So 30 centimeters per second, that's the wave speed or velocity. 5 centimeters, they told us in the problem, that's the wavelength. All right. And then the question mark, we're looking for the frequency. So let's go ahead and write the equation in our equate step. So wavelength times frequency equals velocity. Now, in this problem, we need to switch some things around, right? Because currently this equation is set up to solve for velocity, but we're looking for frequency. So in order to solve for frequency, I need to separate my wavelength. I need to move it away from my frequency, right? Because frequency, in order to solve for it, we need it by itself. So I'm going to divide because the frequency and wavelength are currently being multiplied together, and that's what's holding them together. So we're going to separate them by doing the opposite of multiplication. I'm going to divide by the wavelength on both sides. As you can see over here, that cancels the wavelengths out because we've got one up top and one in the bottom. So we can just cancel those out. And now we are left solving for the frequency. So frequency equals velocity over wavelength. All right, so we're going to go ahead and plug in our measurements. Frequency equals velocity over wavelength. All right, which is going to be 30 centimeters per second over 5 centimeters. All right. So now let's go ahead and handle our numbers. So our numbers are 30 divided by 5, okay, which is going to give us 6. All right. And now we have centimeters over seconds divided by centimeters. Now, when we see that, all right, what we can go ahead and do is whenever we see something in the numerator and in the denominator, we can cancel it out. Just like we saw wavelength up top and on the bottom in the equate step, we see centimeters up top and centimeters on the bottom. So we can cancel those out. So what that gives us remaining is 6. And then we have seconds in the denominator over here. So we're going to put seconds in the denominator in our final answer. Now, whenever we see seconds in the denominator, right, and we know that there's something else that's over here, we know that that's waves, right? Because waves is like, it's not, we don't ever write it really. We just know it's talking about waves per second. You know, just like in our previous problem, we didn't keep waves in our final answer because it's just a placeholder. It reminds us what we're talking about. So when we know that we are talking about waves per second, that reminds us that, oh, we can erase that entire thing and use the unit of waves per second, which is hertz. All right. So whenever we see waves per second, we can replace that with the unit of hertz. All right. So that's how we solve for frequency. Again, I'm moving kind of fast in this video, but just make sure you can slow it down, rewind, review different parts. All right. So we're going to go ahead and solve a problem for frequency right now. Or sorry, we just solved for frequency. We're going to solve for wavelength. And that'll be the last problem we do. Right? Give me 1 second, you all. All right. So let me go ahead and put this last problem where we solve for wavelength um, in here. Okay, so I'm going to paste this problem right in here. We're going to get started. So this is the last problem we're doing. All right. So in solving for wavelength, we're going to use the ICE method. All right. So we're first going to identify the important measurements in the problem. The problem says a wave is traveling with a wave speed or velocity of 40 centimeters per second. So we can write that down, 40 centimeters per second. The frequency of the wave is 4 hertz. So we can write that down. And it says, what is the wave's wavelength? So we know we're looking for something. So we're going to go ahead and categorize all of these. 40 centimeters per second, it told us that was the wave speed or velocity. 4 hertz told us that's the frequency. And then the wavelength is what we're looking for. All right. So now we're going to equate, right? Which means we choose our equation. We've been using the same equation every time. Lambda times frequency equals velocity. But now we are solving for the wavelength instead of the frequency. So to get wavelength by itself, we just divide by frequency. And you see how it cancels the frequency out? All right. So now we have frequency on the other side of the equation. So wavelength equals velocity divided by frequency. All right. So now let's go ahead and plug in our measurements and solve. So our velocity is 40 centimeters per second. All right. And our frequency is 4 hertz. Okay. So we're going to go ahead and handle our numbers first. So 40 divided by 4 is going to be 10. All right. But now we got to deal with our units. So for starters, I see hertz. Whenever I see hertz, remember to change it to waves per second. All right, waves per second. Now, because I have seconds appearing in the numerator and the denominator, just like when I saw frequency in the numerator and the denominator up top, I'm going to cancel out my seconds because when you see the same thing appear in the numerator and the denominator, you can cancel it out. So the units I have left are waves per, centimeters per wave. Now remember, just like in all the previous problems we just did, when we see wave in the denominator, it's not actually there. All right. Give me 1 second. All right, when we see wave in the denominator, it's not actually there. right? It's just a placeholder. It's reminding us what we're talking about. So in my final answer, I don't actually have to include it. All right. So I'm just going to go ahead and erase wave because we don't actually need to include it in our final answer. It's just a reminder for us of what we're talking about. So our final answer for wavelength ends up being 10 centimeters. Okay, sweet. So that is how you do these problems using the wavelength and frequency and velocity equation. Okay, so hopefully this was helpful. Make sure to just practice and review these. And I'll again put out another video for period and frequency. All right, thanks so much and have a good one.